Hello everyone. Let's consider a data set where we have people's first name, last name, and age information. Suppose we want to create data structures in Python to keep track of the data within the data set. I have two different code snippets here. Code snippet 1 is using list of dictionaries to represent the data set. Code snippet 2 is using list of tuples to represent the exact same data set. Both of these code snippets have bugs within them. Please pause the lecture video here and go through the code snippets to identify the bugs. If you're able to identify the bugs, write a comment in the comments section providing details. In code snippet 1, clearly we have a typo within the first key as part of the first dictionary. That's because all other keys as part of both of the dictionaries have all lowercase characters. The program will not crash in this particular line. Instead, it's going to crash on the line where you're making the print function call. That's because we are extracting the dictionary at index position 0 by saying people of 0 and storing that into a variable called p. Then within the print function call, we are concatenating the string hello with the lookup p of key f name where all the characters are lower cases. The key f name does not exist within the dictionary at index position 0, so the print function call is going to crash. It is very annoying that the code is crashing at the print function call line when clearly the problem is as part of the data structure definition here. Let's go through code snippet 2. The bug in code snippet 2 is very subtle. You're extracting the tuple at index position 1 into a variable called p, and then you're concatenating the string hello with p of 1, which is going to be string baker, and you're concatenating that with a space along with p of 2, which is going to be integer 31. Recall that you cannot concatenate a string with an integer. Clearly, the intent of the programmer here is to say hello, first name of a person and last name of a person. What is the fix for both of these bugs? You'll have to mention p of 0 within the second code snippet, and you'll have to fix the typo within the first code snippet. Which one of these is a better way to represent that particular data set? I personally prefer the first way because it is very obvious as to which particular data you're extracting when you perform the lookup operation by mentioning p of f name here. Wouldn't it be nicer if you can create a custom person type to keep track of various details associated with individual people? I'm going to show you a third code snippet which is going to enable us to create a custom type called person. We'll be using name tuple for creating the custom type. I'm going to take this third code snippet and explain to you each line of code. The name tuple type is part of the collections module, so we'll have to import name tuple by mentioning from collections import name tuple. The next line of code is calling the name tuple constructor to create a type called person. Let's look at the details here. For the constructor, you need to pass two arguments. The first argument is going to be a string that represents name of that type, and the second argument is going to be a list of attributes which are going to store the details corresponding to that particular custom type. In this particular example, we want to store f name, l name, and age. So those are provided as the attributes here. You need to follow the exact same rules for attribute names as you follow for variable names. For example, you cannot have space as part of a variable name or an attribute name. What is the return value from the name tuple constructor? That's going to be the custom type that we created. Observe that you need to have the same value within the return value and this first argument here. The return value is going to be the custom type which we are going to use for creating object instances. The string person here is going to be the output that comes out of the type function call if you were to pass this particular custom type object instance as an argument to type function call. Let's understand more about name tuple here. Integer and float are subtypes of the type number. Similarly, string, list, and tuple are subtype of the type sequence. Name tuple is going to enable us to create various types. It is not a type on its own. We'll be able to create custom types like person, hurricane, or any other type that you want to create for storing your data set. Let's talk about how to create object instances. What exactly is an instance? You're just creating one object from the custom type person, and that particular object is called as an object instance. How can you create object instances? You can just mention the type and mention the values within the parentheses, just like how you can say str of 3 to typecast 3 into a string, or call the list constructor to create an empty list object. You can use the person constructor to construct or instantiate a person object type. You're going to capture the return value into a variable p that's now going to store that particular object instance reference into this variable p. Let's talk about how we can access attribute values. You need to mention the reference variable, which is p here, and then dot attribute name. So if you want to extract f name, you'll have to mention p dot f name. So there are two ways for you to create object instance using the custom type that you create using name tuple. The first one is by using positional arguments, which is going to line up the arguments against the corresponding attributes. The second is going to be via keyword arguments. Recall that when you use keyword arguments, you can use any sort of ordering for the arguments. So you'll have to use the same syntax just like you will use for a regular function call. You need to say age equal to some value, fname equal to some value, and so on. So let's talk about the code snippet once bug where we had a typo within the key f name. When you use name tuple to create a custom type person, your code is going to crash immediately when you're trying to create an object instance of the person type. That is really good because you'll be able to debug the problem pretty easily, because the problem will occur within the line where you're creating the object instance. Let's talk about how attribute access works. When you say p.fname, that's going to get the value from the fname attribute corresponding to the reference p here, which is storing this particular object instance. p.lname will get you the string Anderson in a similar way. Let's talk about record class. Name tuple is an immutable type, just like tuple is an immutable type. Record class is a mutable equivalent of name tuple. I'm going to give you an example where we have the same code snippet using name tuple and record class. First of all, you'll have to import a record class from the record class module. It's kind of a weird import because the module name and also the type name here is going to be record class. All other lines of code are going to be exactly the same, other than the fact that you'll be using record class constructor to create the custom type person here. Which one of these types will allow you to increment the age of a person by a value of 1, saying that that particular person had a birthday? That's going to be record class, correct? That's because record class is mutable, whereas name tuple is immutable. Recall that we installed record class using pip install record class as part of the initial Python installation for this course. I'll wrap up this video here. In the next video, we are going to talk about how to evolve our mental model of state.